Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is going to be a quick video today on how to use 3x5 cards to do geometric proofs. And what I'll do is I'll put several different proofs in the description below. It'll be later on the same day that I'm posting this content. So if you see this right after I post it, you might not see those extra proofs in the description below, but it'll be later on today. So if you're watching this later, you'll see those extra proofs. I'm going to list several proofs where you can do this, but here is what you do. And this is a great way to learn geometric proofs. Okay, so I have a key over here. So this, when you see this kind of slanted L, that's going to mean angle, right? If you're a student watching this, then you probably already know what these mean. But if you're a parent watching this, then maybe not. If you see M next to an angle, it means the measure of that angle. And then this little equal sign with a till above it is going to mean is congruent to, right? So congruency, which is kind of similar to equality. And then a linear pair, I'm defining a linear pair maybe a little bit differently than what you might see in your book. The books define these terms a little bit differently sometimes, so you might need to tweak it just a little bit for yours. But here I'm going off of this definition, which is a pair of adjacent angles whose sum is 180 degrees, okay? So this is what's called the vertical angles theorem. This proof is called the vertical angles theorem. I'm given two things. Angle 1 and angle 2 are a linear pair. Angle 2 and angle 3 are also a linear pair. And I need to prove that angle 1 is congruent to angle 3. All right, that's how you read that. And I'm going to show you how. So I'm going to move this off to the side here. The first thing we want to say in any proof is that we have our givens. Right, so angle 1 and angle 2 are a linear pair. Reason, given. And you put the statements on the left and the reasons on the right. Right? So that's going to be the first thing you'll say. And while I'm doing this video, I'm going to be giving you the answers to this. So what you'll want to do is you'll want to shuffle these cards up when you make these and try to mix and match the cards so that way they're all jumbled up and you can properly put the statements and reasons in the order that I'm showing you. Right? The next one, angle 2 and angle 3 are also a linear pair. Right? That's also given. There were two givens. However many givens there are is however many statements and reasons you're going to start off with that have the reason of given. Right? So as I keep going here, I'm going to move these up. That's why I have it in this mode here, because it's going to get a little blurry as I go up here, but I'll show you the finished product here. The next thing we want to say is that measure of angle 1 plus measure of angle 2 is equal to 180. That's the next card you'll make. And that is the definition of a linear pair, right? That's the definition. So I'm just saying what the definition says. And I do that again for measure of angle 2 and measure of angle 3. Okay, definition of a linear pair. Move these out a little more. Move these up. So we can make space for the next row here, right? And sometimes proofs take a few steps. This one is going to take about 8 steps in total, but it's pretty straightforward. And hopefully you'll be able to knock this one out pretty quickly. The next thing we say here, this is a little bit tricky of a step, but since the previous two things were both equal to 180 degrees, we can set them equal to each other. Measure of angle 1 plus measure of angle 2 is equal to measure of angle 2 plus measure of angle 3, because they're both equal to 180. And that, you can call it two things. You can call it substitution property or transitive property. Sometimes it's substitution property and it's not transitive property. But if it's transitive property, then you can always call it substitution property. So the safer bet is to just say substitution property. All right, and move these up a little higher. Move this down. Make our next row here. All right, the next thing, we're on our second to last here. Measure of angle 1 equals measure of angle 3. So notice the measure of angle 2's went away. And that's because of the subtraction property of equality. We subtracted the measure of angle 2 on both sides. And then the last thing, so we're actually not done because what we're trying to prove, remember, is that the measure of angle 1 is congruent to the measure of angle 3. So this is a part where I saw a lot of my students not finish the proof because they were like, oh, well, that's basically the same thing. And it is basically the same thing, but we have to end exactly where they tell us to end. Okay? So the last thing we want to say is actually going to be what we're trying to prove. We're trying to prove this, and that's the last thing you want to say. So the first two statements and reasons, way up there somewhere, Those were what was given. So you state the givens, and then the reason is given. The very last thing you say, the very last statement is what you're trying to prove. The reason is not prove. The reason will never be prove, all right? So I see that mistake a lot too. The reason is never prove, but the other three things, right? This was definition of congruent angles, by the way, if you didn't catch that. So notice that the given right here, that was our first two reasons. These were our first two statements. And then measure of angle 1 congruent to measure of angle 3 is our last statement, but the reason is not going to be prove. Okay, so this word right here is the only word that does not belong in a proof, because it's kind of circular to say, oh, the reason why this is true is because I'm trying to prove it. Well, yeah. All right, so you can see measure of angle 1 is right here, measure of angle 2. They're next to each other. They're a linear pair. They're two angles on a line. And then angle 2 and angle 3 are a linear pair as well. They're on that line. And you can kind of see 1 and 3 across from each other here. They do look like they're the same. Now, I didn't use a straight edge to draw these lines, so they're a little bit crooked. But when you look at these angles on a drawing where they'd use straight lines to make those lines, they always look the same because they're vertical angles, and vertical angles that are across from each other, separated by these two lines, are always equal, which means the angles are congruent. All right, and that's how you make a 3x5 card geometry proof project. So I would highly recommend trying this out. You don't need too many 3x5 cards. You can probably just use leftover cards that you didn't use from a deck. And they're pretty cheap at most stores. You can buy them for like less than $1 at a lot of places. At least at the time of making this video, who knows? Yeah, so I hope this was helpful, and if it was, then I'd like to give you something else that's really helpful as well. I have a guide, a free PDF guide, just a quick little PDF. It's called The 5 Math Mistakes That Everyone Makes and How to Avoid Them. It's a free guide that I made just to help you, wherever you're at, in whatever math class you might be at, to be able to see what kind of math mistakes you're making, identify what kind of math mistake that is, and then it offers a solution to each of the 5 most common math mistakes, and that way you won't be tripped up by the same mistake twice next time. All right, so if you think that might be helpful to you, you can get that. It's going to be in the description below. It's just at my website, myersmathematics.com, and there's also a link in the description below for tutoring if you would like tutoring in any math class from Algebra 1 to Calculus 3, or SAT or ACT math prep. Hope this has been helpful. Have a blessed day.